So thank you very much for joining us. As I said, we are going to be talking about the Linkurious SDK and how to build enterprise-ready graph applications in today's webinar. So first, a quick overview of today's webinar agenda. We are going to do an introduction to Linkurious, then talk a little bit about the success that graph databases are encountering today. Then we will talk about the technical challenges involved with building graph applications. Then we will explain what is the Linkurious SDK. After that, we have prepared a demo for you. And finally, we will show some use cases related to the Graph SDK. Okay, so starting with an introduction to Linkurious. We are a graph visualization startup based in Paris. We have a couple hundred customers around the world, and we are working with customers like NASA, for example, or the French Ministry of Finances, and various other organizations around the world. Our product is used in a wide range of use cases, including anti-money laundering, intelligence analysis, cybersecurity, or medical research. We have two main products, which are the Linkurious SDK, dedicated to helping developers and software architects build graph applications, and the Linkurious Enterprise product, which is an out-of-the-box graph investigation platform. So in the last years, we have seen a growing trend in the world of databases. It's the increasing popularity of graph databases, with a popularity that has increased by more than 500% since 2013. It's the fastest growing database category in the market, with companies like Neo4j leading that trend. In the past year, new vendors have emerged, like, for example, DataStax with its product, the DSC Graph, or new actors. Graph databases have a key value proposition, which is to store the data as a graph of entities called nodes and relationships called edges. What they bring to the markets is the ability to store and query very large connected data sets to extract insights from this data in a way that was not possible to do with former databases. So here is a bit of an overview of the various use cases involved in which graph databases are being used today. So we can see some of them here, including cybersecurity, where organizations store and analyze the connections between servers, switches, routers, and applications to detect suspicious activity or to identify the impact of a compromised asset. With the same sort of data, we see organizations optimizing IT operations, doing impact analysis or root cause analysis with graph technologies. In the field of enterprise architecture, then it's more about the connections between servers, applications, but also metadata or business objectives. And here we see graph technologies being used for things like data lineage or to curate and manage an enterprise architecture. Other use cases involved intelligence analysis. So this is something more reserved to government agencies who are interested in connections between individuals, emails, transactions, phone calls, and social media data. In that domain, the goal is to detect and investigate criminal or terrorist networks. We are also seeing a number of financial institutions either doing anti-money laundering or fraud with graph technologies like Linkurious. This anti-money laundering involves, or AML involves, looking at connections between people, transactions, watch lists, companies, and organizations to detect suspicious transactions or to identify beneficiary owners, for example, and suspicious or at-risk beneficiary owners. In fraud, we see, for example, companies looking at connections between claims, people, financial records, and personal data to detect and investigate criminal networks. So this is a bit of an overview, and every time there's a big topic which is common. It's the existence of complex connected data and the need to find hidden patterns in that data. That's really where the graph technologies are useful. The big problem today is that the graph technology landscape is quite difficult to understand. There are a lot of different technologies on the market, including graph databases like Neo4j, OrientDB, Allegro Graph, Titan, for example, but also graph visualization library like Sigma.js or Viz.js, for example. There are also different search engines like for example, Elasticsearch, which last year released new graph features, but also graph processing systems like Giraffe or like graphics from Spark. So these is quite difficult to understand for a newcomer, and it's a problem because to build a new graph application, you usually need to tie together some of these various tools in a single application. And that's really where the challenges of integrating graph technologies come in. I would say that the number one challenge with developing a new graph-powered application is the cost associated with that. Developing a new full-stack solution requires time, but also skills and money. Another important problem is the topic of maintainability. When you build a new solution from the ground up, it involves technical changes and risks in terms of scalability and expansion. And this risk keep on existing as the project go on and is used in production. And finally, there are also some security challenges with the patching of various pieces of technology into an ADAX solution. Can lead to potential failures and also not necessarily be compliant with enterprise security requirements. So these are some big changes that we see today as a software company helping customers build graph applications and also extract hidden insights from graph applications. I'm going to now let Margot take over.
So hi everybody, so I'm going to give you a technical overview of our SDK and how it actually helps solving those three problems that John just presented. So the main idea of the SDK, it's a full stack application. And the idea here is that you have three tiers. The first one is a presentation tier that uses a visualization library that we developed called Ogma. That enables you to render and interact with graph data in a web application. The second layer is provided by your server, which is a secure server that offers high-level services as API on top of a graph database. And that graph database being the data tier that is composed in graph databases that we currently support, which are Neo4j, Titan, Allegro Graph, and DataStax, as well as a search engine. So that's to give you a broad overview of the different pieces. And now I will move on in more technical detail on each of them. So the idea behind the server is that you can actually deploy it and connect it to your backend very easily. You can deploy it on premise or in the cloud. So if you have a Windows, Mac, or Linux server, or if you want to use Microsoft Azure or AWS, you can deploy it. Just deploy it, and then it's pretty straightforward to connect it to your database. We support Neo4j, DataStax, Titan, and Allegro Graph. And the idea behind it is that you can change that backend without having to redevelop your front end. That provides a seamless transition from one backend to another. It also provides a safe access to your data that enables you to deploy it inside your IT architecture without compromising the security of your data. We have a role-based access control policy on node and edges types. So you can set up what users can see in terms of read and write properties, and you can define groups, and those groups can also be managed by external authentication services, and we support various ones, so such as AD, LDAP, OpenID, and so on. There's also another interesting features, which is the Audit Trail, which enables to record every activity that users can have on the server. So searches they make, notes they see, changes they make to the data, everything can be recorded in an audit trail, in a log. Another interesting secure feature is the ability to define API keys. External web applications are authenticated when they try to make API calls. So everything that comes inside the server is actually secured by that API key. So we mentioned earlier that server also exposes high-level services, and they are exposed as a REST API, and they actually provide services for those external web applications to use. So we have, in terms of capabilities, we provide full text search that can be used to do autocomplete features in web applications, and we also have fuzzy text matching and multilingual support. Another interesting feature is the capability to generate and share visualizations in various formats that you can use for reportings. And you can also share those visualizations between users that are using the same platform. So if I create an interesting visualization on my web application, I can save it and share it with another user. Another interesting feature is the alert system. The idea behind alerts is that you can write query patterns that might be of interest for your analysts, for non-technical users, and they will be able to fetch the results from those alerts, and they will be recreated and displayed on their screen in the web application. So that can be integrated in a larger scale workflow for your users to use. So the idea behind the server is that it's going to provide high-level services that can be used by your presentation layer. So I'm going to talk a bit now about the presentation layer, which is the base for the user interface. So we developed Ogma, which is a JavaScript visualization library that helps you display, interact with data, graph data inside your own web application. So the first way to fetch data from Ogma is to connect to the Linkurious server, and for that we provide JavaScript REST client that you can load as a library in your web application, and that's going to facilitate the connection between the two pieces. Another interesting feature is the ability to develop custom connectors that are going to translate data from any data source into a list of node and edges that you can use in Ogma. So anything you have, either JSON format, CSV, or any database that you can think of, can actually be used as a data source for Ogma if you write the connector. So those are the two main ways to give data to Ogma. And the idea is that based on one is going to be very fast, the custom connector is going to be very good for prototyping applications, but it's not necessarily safe. On the other hand, if you use a connection to Linkurious server, then you can capitalize on the high-level features that we provide. So the idea behind Ogma is to display, interact with graphs, and we put a high priority on the performance behind the library. The idea for that is that we leverage WebGL and JavaScript technologies that enable to achieve that kind of performances. We can scale up to hundreds of thousands of nodes and edges, and we are compatible with all modern browsers. Ogma is used to render data on your web application on the screen. And the idea behind Ogma is that you're going to define styles to actually set the colors and shape and of your data, as well as define different graph layouts that are going to impact how the data is rendered on the screen. And once data is rendered on the screen, you can also design custom interactions, such as custom filtering, hover, selection, drag and drop of nodes or edges on the graph, dynamic grouping, and so on. So I'm going to showcase a small application that we've created for this webinar, just to give you an idea of what we can do. So this tiny application has been developed using Angular 2 as a JavaScript development framework. It's a very small example to show you some high level, to illustrate what we've been talking about and to illustrate some functionalities that we can actually achieve. So the idea behind that application is that on the front end, we are using, as I said, an Angular 2 application. And we are connecting to a Linkurious server that itself is connected to a Neo4j database instance. We have loaded the IMDb movie dataset in the Neo4j instance, and we are using Linkurious to actually serve the data as well as high-level processes. So here, I developed a search bar, and when you type, it's going to dynamically compose a search query that is sent to Linkurious server search API, and that dynamically retrieves the list of movies that actually have that match the pattern that I enter. So you're going to go for Titanic. And when you click on it, I'm actually reaching to a new web page, and information about the node is actually fetched from the database. And here we can see that I've retrieved information about that movie, including some of its properties, so the release date, the studio that funded the movie, as well as the duration of the movie. We can also watch the trailer and have the description of the movie. So this is the Ogma instance that is rendered in that window, and we can see that the movie is displayed here, and we have the actors who actually acted in that movie. I styled I styled the frame the following way: is that I decided to display actors in circle around the movie, and I also choose to display certain type of information. So, for example, actors who have starred in more than 10 movies have that tiny star badge on the top right. So can see that Leonardo DiCaprio has one, Kate Winslet has one, and so on. When we hover on a node, we can have more information about the actors, depending on information that is provided on the back end. And then we can have various interactions on top of those nodes and edges that are actually captured by the canvas. And here what I coded is that when we double click on the node, we actually open the actor's web page. And it works the same way. We fetch information from the node and related links and its connections. And here we have information about movies, about the movies that the actor starred in, including the release date, the number of actors, studio who produced the movie, and the type of movie is actually impacting the tiny icon on the top of the tooltip. Another interesting feature that we have is the ability to dynamically change the style of the rendering. So I designed a different style here that changes the rendering of the screen of the graph. So here what it shows is the size of the node actually reflects the number of actors who starred in it. So we can see that a tiny movie like Marvin's Room, for example, who has 4 actors, is considerably slower compared to Titanic, who has 21. And we can switch back and forth between those modes. So that can be very useful if you have different views that you want to convey to your users about the same data, same graph. You want to emphasize on different features and properties of those nodes and edges. So I'm going to move to the documentation just to give you a quick idea of what you get in terms of features and different examples and what you can achieve. So you have a getting started webpage that gives you an overview of how Ogma works in a technical ways. You have an API webpage with list of functions and parameters they take and description of what they do. You also have an integration section that goes through the different module loaders in JavaScript and how you can actually use the library with those specific module loaders, as well as description about integration into larger JavaScript frameworks, such as React and Angular 2. We've worked with others with success. An interesting page is the examples page because it gives you examples about various operations you might want to do with Ogma. And you have, for each of them, the results on the top of the screen, as well as the HTML code to actually achieve such result. So that's a very nice way for you to copy-paste the code and play with it on your own local installation and machine and achieve results. And we have example like that about various things of them that you can customize. So the looks of nodes and edges, as well as the type of interactions you can have and catch the interactions that the user have on the screen. There's also interesting features that you can see on that web page. For example, you can see the geographical mode that dynamically plots nodes on a map based on the latitude and longitude properties of the nodes they have. So that's the list of examples you have in the documentation. That's in no way exhaustive, and then just a good idea to have snippets of code that you can play with. So I'm going to give back the mic to Jean, who will take it from here.
Thanks, Margot. And now I'm going to mention some of use cases in which the SDK, the Linkurious SDK, has been used, starting with the Panama Papers. So for those who don't know about the Panama Papers, this is the biggest leak in history, and it was started by a team of journalists in the ICIJ, or International Consortium of Investigative Journalism. And they used the Linkurious Enterprise web application to actually investigate the data and reveal evidence of fraud, corruption, and tax evasion around the world. And at the end of that long investigation, they were on the lookout for a way to actually publish the data and make that available to the public. So they quickly decided that they would need for that a web-facing application, and they actually used the Linkurious SDK to build that. With the Linkurious SDK, they were able to quickly ship and build that website that handled heavy traffic once it was released, and using that website, anyone right now can actually search the data and also visualize the connections between companies, directors, and the various individuals involved in the Panama Papers. I do recommend that you visit it if you want to find something new about your country or about the Panama Papers. So that's the first use case. A second use case is the work that we are doing with our partner Cerved. So Cerved is an Italian company specialized in business information and writings, and they were looking for a way to help compliance teams in large enterprises understand hidden relationships between various vendors, companies involved in answering a given tender. So big companies sometimes award contracts through a tender process in which multiple vendors participate and provide the best offers to the company. Of course, if the vendors are linked with one another, then there's a big possibility for conflict of interest and the possibility that that tender process becomes rigged. So that's a big issue for compliance team. Using a graph approach, in a graph for you product, Cerved was able to help Italian businesses detect this sort of potential conflict of interests and use the Linkurious SDK to make these sort of insights available to their clients. Meaning that compliance teams are now able to quickly visualize and investigate potential conflicts of interest between vendors via the graph for your product. I'm going to mention another use case. This one involves a company called Simpler, based in the US. So this company specializes in delivering insights by analyzing healthcare social media conversations. They help doctors, patients, and researchers understand complex interactions in social media. With the Linkurious SDK that they have chosen to integrate in their product, they provide their clients the ability to cut through the noise of complex conversations in social media and understand who are the key influencers across various topics. So these are three public examples of the use of the Linkurious SDK. We do have more clients who use the product in other domains. The Linkurious SDK is really designed to facilitate the extraction of insights hidden in graph data. With it, you can build a secure and enterprise-ready graph application easily, and that can enable your team to find threats and opportunities hidden in graph data. If you want to know more about the Linkurious SDK, there are a few resources for you, including the doc.linkurious.us website, which includes the server API documentation, the server administration manual, but also a lot of resources around OGMA, including the documentation and a demo project called the OGMA Showcase. Finally, if you want to reach out to the team and perhaps set up an evaluation for the Linkurious SDK, you can go to linkurious.js/contact. Thank you everyone for tuning in for today's webinar. If you have more questions, feel free to ask us at contact@linkurious.js. Thank you again. Bye-bye.